picture yet. Let's see if this comes up. Hey, we're live. Yeah, I'm testing OBS. I've been using XSplit, and I thought but I've been having some issues with XSplit, not really related to streaming, but to it's a weird issue that when I want to create a video where I'm sharing a window of pretty much any software, then it locks up the whole computer. I mean, literally the computer, no visual, it's just the mouse pointer stops, everything stops. So it's like completely dead. And it's like the CPU fans and stuff ramp down, so it's like completely locked up. And then I have to like power off the computer from the main switch to restart it. And I haven't found that it has anything to do with any specific software that I'm trying to share the window of. And it doesn't seem to matter if I'm sharing the window from my 4K display or from my full HD display. But I think I'm just getting a little bit more than fed up with the XSplit, at least in that one. So I thought I'd give OBS a try. And now I'm testing the streaming part, and then I'm also going to test the recording a video where I'm sharing a window, another piece of software, or recording it. No. Yeah, needed to have some tea. And it's evening here where I am, local time. So like 9:30 p.m. Central European time. I know there's lots of people using OBS. Have a look at the stream setting. No, stream health. No, it's been excellent all the time. Of course, I don't know if anybody's hearing my audios. Put it in the comments if you can hear me. Maybe I'm just talking and nobody's hearing what I'm saying. It's a pity I can't see the bit rate. In the YouTube studio, live studio, I can't see the bit rate that is being sent. I wonder if I can see it in OBS. Just checking OBS here to see if I can. Live recording, CPU usage, frame rate. Okay, there, in the right hand lower corner, it's like 10 megabits per second. It's nice when I had this gigabit network in the house, and now I have it's only a half a gigabit connection to the internet, but really it seems to help streaming. I've never been able to stream such high bit rates than what I've been doing now, after I installed the wired Ethernet. Really kind of cool. Anyway, I've never used OBS before, so this is my very first time that I've just set it up for streaming, so I don't know if I've done a good job or not. As I said, it does have an audio mixer where you can see how the audio seems to be going out. I have no idea if it's actually getting out to the stream. Well, let's see if we can have some few topics here. As I said, this is OBS testing and random thoughts. Yeah, I've been working a bit with code written in C, and I started to look at the aspects of writing safe C. But oh, heavy book. So I picked up this one. Oh wait, I need to look at OBS because YouTube Studio is like, I mean the delay is like a second. It's so long though. Wait, where is it? OBS. Okay, now I can see what I'm showing. Focus. So I picked this book up, and this is yeah, everybody's sort of like, it's world renowned. You can find it on the internet as a kind of a referenced. I wouldn't really call it a standard, but a kind of a. Everybody makes references to Misra in the safe C domain. And this basically describes what you should and should not use from the C language, specific gotchas in the C language, and how you should handle them. So basically, if you think you knew C, and then you read that book, then you're like learning yourself a new programming language. There's basically no way to memorize all these different rules. But it has a good structure, so it's not like a horribly theoretical manual or book. I wonder if it had a good page with. No, it's not that one. Documentation, define behavior. Is this the? Oh, I thought I'd find a summary page for it. But the good thing is that it doesn't like write like everything is mandatory. It has different categories of their recommendations and procedures. And then they divide up the guidelines into different sections, different types of, different categories. Also, this is the one of the rules. Oh, and I can just. So it's got a category analysis applies to, and then it has got an amplification. It actually explains about it, and then the most nicest point that I think that they have is rationale. Like usually in some rule books and stuff, they just tell you like you have to follow this rule, and then you say, okay, why should I follow that rule? And then it says, oh, you just need to follow that rule. But in this book, it actually does it gives a explanation as to why you should follow the rule. I mean, what's the rationale? Why should you bother? And as I said, there's different categories of those rules. So some of them are voluntary, some of them are mandatory, and some of them are implementation dependent. And the idea is that for every individual project you run, you need to define which of those rules you are following, and then if you make an exception on any of the mandatory or any of the rules, then you need to justify that the code is still safe, even if you're not following the rule. So, and it wasn't that expensive. It was like 50 British pounds. You can order it from their website, Misra website. So I would recommend picking it up. It's actually good reading for even anybody who's working on C, I think. But as I said, the difficulty is that if one has been running development using more standard C methodologies, then the problem is that then you won't remember these rules. And part of these rules can be analyzed and identified by tools, but not all of them. So it even gives a helpful guide per rule if the rule can be identified using analysis software, or if you need to actually manually do a static analysis of the code to be able to find it. So that was a little about writing safe C, and safe C is not the same as secure C. So, you know, if you want to make a C system secure from hackers, then it's not this manual you want to read, because this covers only writing safety critical C code, and it's not the same as cyber secure code. So then they're two totally different categories, and it gets very exciting when you need to combine both safe C rules with cyber security rules. Yeah. What else was on the list? So as I said, random thoughts. I don't know. Depends on if you're the same generation as I am, then you will have remembered Motorola processor, or you would remember Motorola processors, and specifically the 8000 series that predated the world takeover of Intel, that actually dominated the world. So I was actually thinking of doing a deep dive into the 68040, just because as a sort of tribute to Motorola, basically. And then I was thinking of setting it up in a multiprocessor configuration also. I know, completely pointless project. But there was in the days when those processors were common, there were lots of single board computers, just like we have microcontrollers today. So you know, today you have a system on a chip which basically embeds a processor. You know, maybe not the I/O capabilities, the memory management, and all that's built into one single chip. But in those days, everything was separate, discrete logic. So I was actually thinking of, I mean, lots of people have done 8000 projects with FPGAs. So they just put all the processor emulation and all the supporting circuitry into one FPGA chip. But I just thought, the tribute to the real Motorola H, I was thinking that the processor, like, it would be cool if the processor was original, like the original chip, and everything else around it could be whatever modern stuff, like interface. Just so the one can say the one has a native 68000 processor, and specifically the 68040 with the floating point unit and the memory management. I mean, there are 68050, 60. There was no 70, not that I can remember. So there are a few generations, but they're very expensive and very hard to come by. The last 68000 physical processor that's easy to get a hold of with a with not being surface mounted, then that's like the 68040. But there's still actually there is a bunch of 68000 derivatives out there, but then they're based on 68000, which has an 8-bit bus and restricted address bus. So basically the 68040 has a native 32-bit bus. So the data bus is 32-bit. So you get 32 lines on the data bus, not 8. So there's lots of 68000 even as system on the chip solutions, but then they're based on 8-bit an 8-bit data bus. And then partially lots of them use what was it, the multiplexed address buses and stuff. So not really they're real cool. But anyway, we'll see. I've actually ordered the found on eBay. I found 68040, and I've tried to order one. I'll see if it ever arrives. But they're not cheap. I mean, you can buy lots of system on chip. You know, ESP32. You can buy a whole pile of them with what I paid for that processor. But I don't know if it'll ever be a project. Might be that the processor will just be a artifact on my shelf. And as I said, it would be more like a tribute to original, the original massive single board computers that were developed in the 80s and 90s. Or was it? Oh, it must have been the 90s. And then, of course, you have the Amiga, Commodore Amiga, and Atari, and other computers also used 68000 processors. You can get a lot of documentation on it, and the pin layouts and all that stuff for knowns. Yeah, and then I also stumbled on, if you're the same generation as I am, then you will remember TTL logic in DIP packages. And I was like, investigating, like, does that stuff really exist still today? And I actually went out to a very large electronic vendor, and I found pretty much every single 74LS XX series chip available in stock in thousands. And I had thought that the world had basically given up on DIP packaged TTL logic like 20 years ago. But no, it seems like it's totally valid stuff. And they weren't even that expensive. So I also bought a pile of those. So I was thinking of running a bit of a course YouTube series on TTL logic. And then combine with the insane Motorola project. Because I really liked the Motorola CPUs. I thought they were really cool. And the instruction set and the memory layout and everything. much better than what Intel has. But the thing is that this is the reality of life and the universe and technology. It's very seldom the best technology wins out. It's always the technology that basically has the most marketing backing, or other types of financial backing. So TTL logic in DIP packages still exists. So when you think you're really old, and you feel sad about it, go look at, and you beat into electronics. You just go look at the catalogs online for electronics, and okay, there's a lot of surface mount technology and a lot of new stuff. A lot of people, of course, build the main core out of some system of the chip FPGA solution, but basically you can still find, any 555 counters, standard power transistors. It's exactly the same stuff that I bought and built stuff of when I was a 16-year-old. They haven't disappeared anywhere. Yeah, resistors, transistors, thyristors, diodes, LEDs, you name it. LED displays, the same stuff. So the knowledge one has from those days is still applicable. And then when one goes to industrial applications, I have seen some really, really old stuff in industrial applications. Stuff that I personally would have thought had disappeared from everyday use, but then I said, but customers use this still, and I was like, what? Yeah, and if anybody's been paying any attention to the new videos that I've been putting out on the channel, I've been moving a little bit towards revitalizing my learning electronics series. I kind of started it up, but it was a little bit weak, and then I started to invest more in that. I could actually show what I've been doing. Oh god, this is a heavy book. Let's have to go back to OBS so I can show I get it the book in the frame correct. So anyway, let's see if I can show. Oh man, heavy. So I've been I have this book. Not that thick. How many pages does it have? Is that really true? 1,140 pages. No, but anyway, this is actually a very cool book. It actually educates you in. It's been revised, so this is not. There are many editions of this book, and this is like the latest edition, and it goes through all aspects of electronics in a very practical way, and then it has workshop content, so you can actually do labs and investigate yourself. So I think it's actually a very good book. Not that cheap, as usually these technical books aren't that cheap. Maybe I should show the other. Wait, I just need to go get the other book. Yeah, they say you don't need books anymore. Oh, why do I keep on? I got a box on the floor and I keep on knocking it over. Oh, come on. Put the stuff back in again. I really should move that somewhere else. Okay, that was the Art of Electronics. That's basically the workbook, you know, the study book. Self-contained, so that study book you can actually use without any other books on the same series. So don't worry, you can actually buy that book and you're off and running. But it contains references to this one. Right, get it in front. 3rd edition. The main art of electronics. Art of electronics. And this is how many pages to this? Yeah, it's 1,237 pages. No, 1,227 pages. And this book is more theoretical. So it actually it's a real heavy-duty thing. But the good thing is that in this more practical-orientated book that I just showed you, Learning the Art of Electronics, it makes references to this book. So when you're reading that, and then you say, okay, for this specific section, I would like to have more theoretical knowledge, then you can dive into the appropriate section in here, in this book, and then get more information or be educated. So I think it's very practical. And then I bought this one also. That one, The Art of Electronics, the X chapters. And what this is more like weird electronics, like strange things, like, normal. It's stuff off the beaten track of various kinds in the field of electronics. And then I lost practical. I mean, of course, there's many other. I don't really have that many other books. Then I start getting into, like, stuff that you can get off online. So once you've gone through those basics, then you know what you're looking for, and you can probably, if you want spec sheets or simple schematic diagrams of stuff, then you can find those online. So you don't need books for those. But I also got this one, Practical Electronics for Inventors. So this is a fantastic manual. I mean, basically, it's sort of puts you in the shoes of an inventor, and you're like sitting there, and you want to make, you're working on something electronic, and you want to do function X, or you want to do something specifically, filtering or monitoring or rectifying or whatever. Then you can actually go into here, and it will actually give you a hint how to what kind of a circuit you need, what kind of a solution. So anyway, that's a bit of information overload. But as I said, you don't need to read every single page, because that's not the. So I go from the training material, and then move on into the more theoretical parts, and then pick some interesting cases from the X-Files, and then the inventor thing. I don't know if I will directly have use for that. Maybe I'll have to invent electronics someday. You never know. Have to be flexible. So let's see. So that was the last subject on my list there. And the stream has been now running for half an hour. That's usually how I keep it, like half an hour, 45 minutes for each stream. Yeah, I know it's nearly Christmas, so if this is the last live stream I make before Christmas, then happy Christmas, everybody. I'll probably might be making a live stream before New Year, or even on New Year's Day. We have a little bit of recommendations to do to our friendly pathogen that's going around. We have recommendations not to mingle and go out and have big parties, so I might actually be stuck at home with a whiskey and a gin and tonic, so I might actually pop a live stream. But we'll see. And well, OBS seems to have been pretty stable, so now I'm going to stop the stream and I'm going to check the quality and see what ended up on YouTube. And if it's worth keeping, then I'll keep. If it turns out to be junk, I'll just delete it. So anyway, well, we'll see you in the next live stream.